We started section 2.3 last time, and in particular we were working on Venn diagrams. We were using our Venn diagrams for talking about visual, sort of interpretations of some set operations. We had intersection, union, one that was called relative complement or relative difference. Relative difference is what we talked about. We did complement another day. Relative difference, and we did Cartesian product, right? Those are the ones that we did last time. So we're going to take a look a little bit more into the Venn diagram interpretations for different sets. So we have an example here, and it says we're going to use a Venn diagram to shade the following sets. What I'm going to show you actually is something that has changed over time about how I show to do this, and it is sort of the method that I find to be the most user-friendly, so I'm kind of attached to it. So I'm going to show you how to do this, and in particular, what I'm showing you is what I expect to see on your paper. There are other ways to do this, but the more complicated the diagram gets, the harder other ways are to actually interpret. And this method works really, really nicely, even if the diagram gets really complicated. Okay, so that's why I'm going to use this one. Now, we only have two sets listed here, A and B, so we need a Venn diagram that has two circles in it. And we drew those, several of those last time, and they look like this basically. We'll label them sort of in order, A on the left, B on the right, and the universal set U on the outside. Now if you'll remember, this U right here isn't universal set, it means what? Union. Okay, so we're looking at a union here. What does these little, bars on the tops of A and B mean? Do you remember? Complement. So we're looking at complements here. So what I want to do first is I want us to label the areas of our picture. In particular, we're going to label the outside of circle A as 1, inside between them as 2, the outside of B is 3, and the outside with the U, the universal set, is 4. There are only 4 regions on this graph. That's it. Okay, you put another number in one of them, and you've got actually 2 spots where you've put a number in. 2 places in the same diagram, portion of the diagram. All right, so these are our 4 numbers. If you put your numbers in a different place, it's not going to hurt anything. Your number description is going to look different as you're working, but what you shade in the end will actually match up. Okay, so these are our 4 regions. Now, what we're wanting to do is we're wanting to find a complement and B complement, because those are the 2 sets over here that we're trying to find information about. Okay, so you guys told me what complement meant, or what that notation meant, that it meant complement. What does it actually mean in terms of this picture? Which numbers are in a complement? Close.
3 and 4.
Just 3 and 4. So complement means everything that's not in this case, A. So 2 doesn't get included because it is in circle A, right? But 3 and 4 are not, so we're going to write down 3 and 4. B complement. What numbers are not in B? 1 and 4. And this is almost like working with arithmetic when you're really young. You kind of put the line underneath it that says, and the answer is. That's what that line really says, right? And the answer is. And what we're actually trying to find of these 2 sets is their union. So if you remember from last time we talked about union, union is a marriage. Yours, mine, and ours. Everything that's in either one of them gets included. So what numbers am I going to write down? 1, 3, and 4. And do I need to list 4 twice? No, there's no reason for that. This actually gives me the regions that I'm now going to go back and shade. So if I come back to my diagram, I'm going to shade region 1, region 3, and region 4. Does that make sense? Okay. If you forget to do the shading, you're not following the directions, because the directions actually were to shade the diagram. So occasionally I have somebody who's done all the work, but then they forget to go back and shade. So don't forget that part of it. Beth?
Should we put brackets around the 1, 3, 4?
You don't have to. We're just using it as labels for the area. We're not using them as elements in a set. I mean, they could be, and you could put them there, and that'd be okay, but they really are just representing sort of the portion of the picture instead. That's a good question, though. All right. Number B, 2B, is more complicated. Why?
Of the intersection of 2 sets and then the union of that with another set.
Okay, so my first issue is that there's 3 of them,
Yeah.
right? The 3 of them already makes the diagram more complicated. So let's start with what a diagram basically looks like when you have three of them. It looks more squarish just because we need more space inside. We have circle A and circle B like we did before, but then we need circle C at the bottom. It starts to look like the Olympic rings, right? A little bit. I tend to label mine as A on the top left, B on the top right, and C on the bottom, with the U for the universal set on the outside. Again, it's just the convention that I'm using. If you do it that way, then it's going to match my pictures. But as long as you have the correct portions shaded in, we're all good to go. So on this diagram over here, the next thing I did is I put numbers everywhere, yeah? We're going to do that here too. We're going to start in the top left of circle A and just go straight across. So 1, 2, 3. In the middle, 4, 5, 6. In the bottom is 7, on the outside is 8. Just kind of left to right, top to bottom. Now, it is nice that in this particular one I don't have any complements, so I don't have to worry about thinking about complements. I just have to think about the sets themselves. And it's also true that I have parentheses in this one. So what the parentheses tell you is where to start, yeah? So we're going to start inside our parentheses. So we're going to write down what is set A. So what numbers are inside set A? 1, 2, and it is 5, 4. I'm going to write 4, 5 just so they're in order, but yeah. And then what numbers are in set B?
2, 3, 5, and 6.
2, 3, 5, and 6. And the answer is, I want their intersection. So intersection is where they cross, where they meet what they have in common. What numbers do they share in common? 2 and 5. And visually, if you go back to the picture, that should make sense. 2 and 5 are that overlapping region, correct? For the circles A and B. Okay, so I've done the part that's in parentheses. The next part is that I'm supposed to union that with C. Well, in order to do that, I need to write down what C is. So what is C? So what numbers, in other words, are in C? 4, 5, 6, and 7. And I've got my line, and the answer is I want to do the union. So I have the A intersect B above, and I want to union it with C. So a union means I get everything. I list all of them. So I'll start with the smallest, which is 2, and then what do I have? 4, 5, 6, 7, and I go back and I shade those respective regions. So region 2, region 4, region 5, region 6, and region 7. Sound good? Very nice. One more example like this, and then we're going to switch gears on what we can use Venn diagrams for. This is much like the last one. There's 3 symbols, or 3 sets rather. I've got the union intersection, I've got a set of parentheses, but I also have some complements. This kind of merges the first 2 examples together, okay? So we're going to draw our diagram same way we did before, a large rectangle with 3 overlapping circles. And we're going to label them A, B, C, and universal. And we're going to number them 1, 2, 3, 4, 5, 6, 7, and 8. All right, we're not working necessarily left to right. We're working inside the set of parentheses, which happens to be on the left here. But inside the set of the parentheses, I have A, and I have B complement. So let's write down A first. What numbers are in A? 1, 2, 4, and 5. Now B complement's a little bit more messy in this diagram than in the last, the diagram we had B complement on part A. Right? I got lots more stuff that's not in B. So what are all of my numbers that are not in B? 1, 4, 7, and 8. Is everybody good with those numbers? See where they came from. Right. All right, so, and the answer is, am I looking for the union or the intersection? The intersection, and intersection means what they have in common, where they overlap. So, in terms of this particular picture, what do they have in common? 1 and 4. Okay, we're done with the set of parentheses. Moving out from there, I see that I'm supposed to be doing an intersection of this one with C complement. So let's figure out what numbers are in C complement. 1, 2, 3, and 8. And this time, I want what? I want the intersection here. So intersection is what they have in common. And that would be the number 1. And if I go back to my diagram and I shade region 1, I'm done. So who said you can't take something visual and turn it into a very organized, structured process? I actually had a student, this has been eons ago now at this point, maybe 10 years, who showed me this when I was doing it a different way. And this just felt so straightforward and logical. I love the numbers in there. It's very specific. The way that I did it before, and if you have seen this before, you know what I'm talking about. If you don't worry about it, is that I would cross-hatch things and shade them different directions. And the more complicated the diagram got, the harder those cross-hatchings were to really see. And this one just avoids all of that so very nicely. So, all right, so this is one of the issues that we're going to work with Venn diagrams. There's another one though, okay? So the numbers here, as Beth and I were having the discussion about, represented the area of the piece of picture, right? The region that it was in. They didn't really represent like numbers. I could have used letters, in other words, right? It wouldn't have mattered. Well, we're going to change the meaning of our numbers right now. As we work with the next set of Venn diagram examples, the numbers in here are going to actually represent elements. That is how many things are inside of that portion of the circle. So if you see a 5 in there, it means that there's 5 apples in the circle, or 5 people in the circle, or 5 something that actually fit into that category, okay? So the numbers here mean something different. All right, so this one tells us to draw an appropriate Venn diagram and use the given information to fill in the number of elements in each region. And you see the notation where it says N, and then it has the parenthesis, and then it has the set names, right? Okay, so for starters, let's just draw the big old Venn diagram picture with the 3 overlapping circles. We won't put any numbers in it to begin with because that's actually where we're going to end. Okay, so going through this list here, if you're just like me, I know none of you are just like me, but if you're like me in this, you might be tempted to start with the very first thing on the list and try to figure out what to do with it because it's the first thing on the list, right? I mean, you work from top to bottom, left to right. I mean, that's what I do. The problem is that the first thing on the list talks about the number of items in Circle A, and the problem is that there are 4 regions that include Circle A, right? Or that are inside of Circle A. So if I have 24 items, I've got to figure out where to put the 24 items. Do I put them all here? Do I split them up into a couple of regions? Do I put a little bit everywhere? And if so, what do I put and how many items where? I don't know about you, but guess and check doesn't work very efficiently for 24 things. There's infinitely many, well, not infinitely many, there's finitely many, but it's a lot of ways that I could divvy up the number 24. So that's probably not real effective. And if I can't do it with Circle A, I can't do it with Circle B, and I can't do it with Circle C. So everything on that top row is unhelpful pieces of information at the moment. So let's go to the second row. The second row talks about where A and B intersect. Well, here's Circle A and here's Circle B, and they intersect right here. How many regions are included there? 2. That's better than 4, yes, but it's still 2. And they intersect with 10 items. So there's fewer ways that I could divide up 10, but there's still a lot of them, right? I could do 10 and zeros, I could do 5 and 5, I could do 8 and 2, or 8 and 2 the other direction. Lots of options. I don't want lots of options. I'd like to have just one option. So this entire middle row, off the table, because it's all overlaps in 2 places. So, third row, right here. This says A intersect B intersect C. Where do all 3 circles intersect? The very middle, and there's exactly 1 region there. So that's the place we want to start. It doesn't always look like this, but you want to figure out with the information given, which one gives you the information for the 1 region that doesn't require you to guess and check anything. That's what you're looking for. So in ours, it is the dead center, and it tells us there's 6 items right here. So that's where we will start, and we will write a 6 in the very, very center of our Venn diagram. Now here's the cool thing. Oh, there's one more piece of information here. It's the worst piece in terms of what we need to fill in. It says the number of items in the entire diagrams. What is it, 50? So that's everything here. It's going to add up to 50 when we're done. So we don't want that piece of information till the very end, right? Yeah. Okay, we do, however, have the ability now to go back up a line to that middle row, and we can use that middle row now. So when this says the intersection of A and B, and we talked about it being this sort of a fish shape here in the middle, we said there were two regions. The kicker is we already know what one of those two regions is. It's 6. And if this whole region right here, the two of them put together, is supposed to be 10, how many more need to go here? 4. So these two added together will be the 10 that I was supposed to have. So I can have 4 right here. And if you're kind of keeping track, that means we've taken care of this piece of information and this one. I'll just mark them off as we go. If we keep moving along that middle row, the next piece it talks about is the intersection of B and C. Okay? Diagram-wise, that's right here. I already have 6 of them accounted for, and there's supposed to be 8, which means how many go out here? 2. That's right. So I have a 2 in this piece. And I've taken care of that piece of information. The next one says A intersects C. So that's this fish over here on the left. Still has a 6 right there, but combined they're supposed to be how many? 15, so I still need 9, exactly. So there will be 9 out here, and I can mark off this piece here. It's done. Okay? Everybody okay so far? See where all the numbers we have in there so far came from. Veronica.
Did you get 9 again?
Vanessa, sorry, I have Veronica in the class. Where did I get the 9? Good question. Okay. So these two numbers have to add up to 15, and I already had 6 of them. So we did 15 minus 6 to give us the 9. Any other questions? Okay, if we go back to the very top now, where it told us that N of A was 24. We didn't like that at the beginning, at least I didn't, because there were 4 regions here. But 3 of them are now filled in, aren't they? So I've got 4, 6, and 9 for a total of how many? 19. That's 19. There's supposed to be 24. So how many am I missing? 5. So I will have 5, whoops, in the outer part of circle A. And I will be able to mark off that I've done N of A equals 24. It also tells me N of B equals 24. So in circle B over here, I have 4, 6, and 2 for a total of 12, which means how many more do I need? 12. So I will have 12 on the outside of circle B, or in the outside of circle B. And my last piece says N of C is 26. I have 9, 6, and 2 for a total of 17. And it's supposed to be 26, so how many am I missing? 9. So there are 9 more out here. We've done that one. I'm still missing one thing. What am I missing? Yeah, the number that's in the outside of the universal set, right? Part over here. So somebody's going to grab something, calculator, whatever. Maybe you're going to do it in your head. You're going to add up all these numbers, right?
It's 47.
It's 47. And it's supposed to be how many? 50. So how many are missing? 3. So we will put a 3 out here. And we're done. Okay, so you might look at this and say, okay, that was a puzzle. How would I use that, or what would I use it for? What's the point? And it is a puzzle, and I contend that Sudoku is a puzzle as well, and nobody asked that question. But there is a use for this. That's what we're going to look at next, okay? So this is how we structure it. This is how we put the numbers in and fit everything in. So let me show you now the why. Sound good? And we're going to start with a very simple one on a why. It talks about Joe Long. Joe Long works on albums for musicians. Last year he worked on 12 projects. He wrote and produced 2. He wrote a total of 5, and he produced 7. And then asked us some questions. Now, could we do the problem without a Venn diagram? Potentially, but the more complicated that it gets, the harder that becomes. And the Venn diagrams work so very nicely at solving this type of a problem. So that's what we're going to use the Venn diagrams for. So you have more space on your very bottom of your paper. I'm going to write mine here in this awkward little spot. Not very much space, but I'll do okay. How how many circles do I need in my rectangle? 2. Why do I only need 2? Yeah, there's only 2 categories of things that talk about what Joe did, right? Writing and producing. So when I draw my circles, I'm going to actually just label one of them write and one of them produce. And I'll put universal set on the outside. And we're going to use the information that we're given to try and fill in what numbers of items go where in this diagram. It says that he worked on albums for musicians. Last year he worked on a total of 12. So that tells us that everything in the entire rectangle, circles plus rectangle, all of it has to add up to 12. Okay, so that information is not so super helpful at the very beginning, but at the end we'll need it. It says he wrote and produced 2. What does that tell us?
That goes in the middle.
That goes in the very middle, and that's the most helpful piece of information because it was a very specific location, the overlap part, and it said 2. Now it says he wrote a total of 5. So what am I going to do?
3 in the other.
So I need to put a 3 out here. Why do I not put a 5 out here? Catherine, I heard you say.
Because he wrote a total of 5, and so he took part in the writing of the 2 that are in the middle.
Right. That 5 included the 2 that he wrote and produced, right? Okay, so we don't want to put the 5 on the outside. We want to put a 3 on the outside so that that region of the entire region of writing adds up to 5. And then it says he produced a total of 7. So I need to put a 5 on the outside in the produce circle so that the 5 and the 2 add up to the 7. How many of my projects are now accounted for, or Joe's projects are now accounted for? 10, which means I need to put a 2 on the outside. So on the other 2, he did something else. Wasn't writing, wasn't producing, maybe he sang, I don't know. But he did something else on the other 2 projects, right? Sure. The diagram is the hard part. The questions are usually the easy part because you're just relying back on the diagram. So, how many projects did he write but not produce? 3. It's in the diagram. How many projects did he produce and not write? 5 in the diagram. And how many did he neither write nor produce? 2. And you're done. The questions have to match your diagram. So if you mess up writing your diagram, you know, there's points away from that, but the points will be still counted in your favor if your if your answers to your question match your diagram. Does that make sense? I don't think I worded that very well, but did you understand it anyway? Okay, good. All right, last one. This one becomes more complicated. The youth group was asked the questions regarding songs that they had learned as children. Upon surveying the 34 youth, the following were obtained. 15 had learned Jesus Loves Me, 19 the B-I-B-L-E, 28 This Little Light of Mine, 13 Jesus Loves Me and This Little Light of Mine, 15 Jesus Loves Me, the B-I-B-L-E, 14 the B-I-B-L-E and This Little Light of Mine, and 13 had learned all 3. Okay, so we got a lot of information, about how many categories? 3. There are 3 categories. So when I draw my diagram on this one, you know what, I'll come back over here, there's a spot. I need 3 circles. And honestly, every time I do it, I label the circles with the information. I don't think there's anything super helpful about calling them A, B, and C at this point, because then I have to remember which one was A. I don't like that. I'd rather just diagram, put the words into the diagram. So as they were listed, Jesus Loves Me was listed first, so I'm going to call the top left circle Jesus. On the top right circle, it says, or going in order, it's the B-I-B-L-E. So we'll put the B-I-B-L-E over here. And in the bottom circle will be this little light of mine. And I'll just write down here, write light. And we'll put a U for universal on the outside. All right, so using the pieces of information they gave you in this, listing, which piece of information is the most helpful?
The last one.
The last one. 13 had learned all 3. So what will I do with that piece of information? I'll put a 13 in the center of my diagram. All right, what would you like to use next?
The next one.
So the 14, like the one right above it, just kind of going backwards. So it says 14 had learned the B-I-B-L-E and This Little Light of Mine. Okay, so we're going to take care of this one next. So the BIBLE in this little light of mine is the overlapping fish on the right. Yes? So what do I need to put in the other part of that fish region? 1. So that the 13 and the 1 add up to 14. Very good. You guys said you wanted to go up, so we'll go up to the next one. 15 had learned Jesus loves me in the BIBLE. So that's the top fish, right? The top overlapping part. And I already have 13 in the middle, so how many more do I need? 2 in the outer region here. So the 2 and the 13 add up to 15. And the last doubling up piece says that 13 had learned Jesus loves me in this little light of mine. Okay, so that's my last overlapping piece. I've got 13 in the middle, so what am I going to do now?
0.
There's going to be a 0. So it's totally fine to have a 0 in this diagram. Okay, looking good. If we keep working our way up, it says 28 had learned this little light of mine. Okay, this little light of mine was the bottom circle. I have 13 and 1, which is a total of 14 already there, and it's supposed to be 28. So how many are missing? 14 are missing. So I'm going to have 14 in this little light of mine portion on the outside. The second one up from there, 19. 19 had learned the BIBLE. So in my BIBLE circle, I've got 2 and 13 and 1 for a total of 16, which means I'm missing 3, because it was supposed to add up to 19. So there's 3 in the outer part of the BIBLE circle. And then I have 15 had learned Jesus loves me. So I have 2 and 13 already, which is a total of 15. So how many go on the outside of the Jesus loves me circle?
0.
Another 0. That's okay. There's a 0. I mean, no doubt we should teach all these kids all these songs, right? Definitely the next step in the process. But I need one more piece of information. Where is it? Universal. And it's the 34. Right up here, it told me that I had 34 youth, yeah? So how many have I accounted for with the 2, the 13, the 3, the 1, and the 14 in my picture so far? 33. So I'm missing 1 very sad child. Musically deficient. Got a 1 out there. Okay. We're going to answer the 4 questions. Yeah, 4 questions now from this diagram. All right, it says, how many children had learned exactly one of these songs? So which part of the pictures is that?
The outside portions.
Yeah, it's these picture parts, right? And if I add up 0, 3, and 14, I get 17. So there is 0 plus 3 plus 14. I would encourage you to write those down so that if you do happen to make a mistake, I can figure out what it is you did wrong. Okay? So 0, 3, and 14 makes my 17. At least 2. Every time I teach this, there's people that get confused with the phrasings, so be careful. At least 2. What does at least 2 mean? 2 or more. So it means they've learned 2 or 3 songs. So in our picture, where are my 2 or 3 songs located? Which numbers are they? The 13, the 2, the 1, and there's a 0. Yeah. So those who had learned 2 songs are the 0, the 2, and the 1, and they'd learned 2 songs was the 13 in the middle, for a total of what? 16. How about none of these songs? That was the sad one on the outside. And this little light of mine only,
14.
that's the 14. Oops, 14. Okay, the questions go quickly after you do the diagram, yes? Yeah. All right, last question for today. Is the Cartesian project commutative? Why or why not? So we haven't officially defined the word commutative. We don't do that until chapter 3. But commutative means you can change the order. Okay, you can switch the things. So if you'll remember, Cartesian products put numbers into ordered pairs. So you have a group here, you have a group here, and you put them into ordered pairs according to the location of their group. So in particular, what this is asking is, in fact, I'll flip back to my Cartesian product over here that I did last time. Is this arrangement the same as if I switched the order around? If I made this 1x, 2x, 1y, 2y, 1z, 2z, is it the same as the original one that I had?
Now, if they're on a Cartesian coordinate plane, then no, you would get two.
Yeah.
different points.
That's the easiest one to think about is the Cartesian plane that you guys know, right? So they have the same number of items though if we switch them, right? We'll have the same number of elements, but we don't necessarily have the same elements. And that's the easiest argument for why it doesn't work as well. So the answer is no, because in general, this is an example, but in general, for example, 1, 3 would not equal 3, 1. So in general, AB does not equal BA. So the answer is no. And that's interesting because we did intersection and unions, right? And those were interchangeable, right? The sets could switch orders, but it doesn't work for Cartesian products.